Hi guys, this is Mrs. Foy, and this is a quick little screencast about mixtures of matters, elements and compounds, and the conservation of matter. So this is chapter 3 in our textbook. I am not talking about chemical versus physical change and chemical versus physical properties or states of matter. I did that in another screencast, and so you can go to Lee Foy, my YouTube channel, or you can use this link right here to get to that screencast. So I've already talked about that and going to go on to talk about some more things today. So guys, matter we know can be solid, liquid, or gas. And we can divide matter into two basic big categories. Matter is either going to be a pure substance, which is either an element or a compound, or it's going to be a mixture. And if it's a mixture, we can either say it is a heterogeneous, hetero means different, versus homogeneous mixture, homo means the same. So the first thing we're going to talk about is a pure substance. So a pure substance is either an element or it's a compound. An easy way to tell the difference between these two is that if you look at the formula of an element, it is going to have one capital letter. If you look at the chemical formula for a compound, it is going to have two or more capital letters. So for example, you see the periodic table of the elements up on the wall. All of those are elements. So like gold and silver and oxygen and nitrogen are elements. Compounds are going to be two or more elements that are bonded together, like two hydrogens and one oxygen are bonded together to be water. Or you could take nitrogen and bond it to oxygen and you could make nitrogen oxide. Those are examples of compounds. So this is a great little diagram that tells us how can we tell whether something is a mixture or if it's a pure substance. So the first question we ask ourselves is, can the material be physically separated? Not in a chemical reaction, but just physically separated. So can you filter it? Can you divide it into two separate piles? If the answer is no, then we call it a pure substance. And furthermore, if I wanted to divide a pure substance either into an element or a compound, I would have to have it go through a chemical reaction to get it to go through a chemical change and break the elements into compounds. So for example, if I were to take water, which we know is H2O, and I were to run an electrical current through that, I can actually separate the hydrogen and the oxygen in water into their pure elements. So this is oxygen, this is hydrogen and this is oxygen. And I can do that. That's called electrophoresis, but you actually have to run an electrical current through water to get it to separate into its elements. And I'm going to show you this in lab. And see the little bubbles here? That's an example of a chemical change. So that should give you an idea that you actually have to chemically separate these. In a mixture, we have two different types of mixture. We have a heterogeneous mixture and a homogeneous mixture. Remember, hetero means different. So a great example of a heterogeneous mixture would be something like granola or a pizza with all the toppings on it, right? So you can see that they're very different things in that mixture. And there are two different types of heterogeneous mixture. There are things called colloids and suspensions. We're not going to spend any time talking about that in this class this year, but a suspension would be something like mayonnaise that has eggs and oil that's beaten up together to form that substance. And a colloid would be an example of like whole milk, that if you let it sit over a while, it would separate with the fat on the top. But a homogeneous mixture is something where you can't see the physical materials that are separated. It just looks like it's homogeneous. It looks like it's all the same. And another word for a homogeneous mixture is called a solution. Okay, so if I looked at this material, if this was, say, Kool-Aid, a blueberry Kool-Aid mixture in water, this would be a homogeneous solution. And if I took this beaker of sand that had some pebbles and rocks in it, that would be an example of a heterogeneous solution. Neither one of these is a pure substance, because a pure substance is something that can't be separated by physical means. I can separate this into bigger and smaller pieces, and I could separate the sugar in my Kool-Aid by boiling off the water. So neither one of these is a pure substance, but the homogeneous solution would be, the homogeneous mixture is an example of a solution. So in a solution, what we see is we usually have some type of solvent, which is the material that's there in the majority. And then we have smaller particles that are dissolved in that called the solute. So my favorite example of a solution is chocolate milk. The way you make chocolate milk is your solvent is going to be milk, and then your solute would either be chocolate syrup or it could be Hershey's Quick, like the powdery stuff that you mix. In each case, this would be the little chocolate particles, and that would make a solution or a homogeneous mixture of chocolate milk. Here are 3 different examples of some mixtures, but only 2 of them are homogeneous solutions. Can you guess? You're right, it's salt and sugar, because I can't see the difference. I don't see the individual particles. The sugar has dissolved in the water, and so is the salt. But sand and water, I can see the various mixtures that are separated components. And so that would be a heterogeneous solution, sand and water. So solutions are not always liquid. For example, air is a solution or a homogeneous mixture, because air is a mixture of nitrogen and oxygen and water vapor and carbon dioxide, along with some other things, but we don't see the individual components, and so that's why it's a homogeneous solution. Steel is an example of a solid that is actually a solution, because steel is a mixture of metals and elements like iron and aluminum and some things that are melted at very high heat together to form this solution that we call steel. But I don't see the individual iron and aluminum components in that. So we can separate mixtures, and there's actually 4 different ways that we can separate a mixture, and some of these we're going to do in lab. So this is an example of filtration. So you can take a solution and you can use a funnel and a piece of filter paper, and it will trap the larger particles in the solution and will give you the solvent at the bottom. So that's an example of a filtration. Crystallization is an example of where you let the liquid or the solvent evaporate off. Sometimes you heat it gently, and what you have left, if you have left the solid material that is there, forms crystals, solid crystals in some type of container. Chromatography is where you use some type of solvent, and you put your material here. You guys probably did this in middle school, probably used different ink. And what happens is that you have a piece of porous material like paper, and as the solvent gets wicked up through the paper, the different types of ink are separated out depending on how big they are and how heavy they are and when they get caught in the paper. So that's called chromatography, and we'll do that in class as well. And then distillation is something we won't do this year in class, but basically distillation separates materials based on different boiling points. And so that's going to be something that you do in a more advanced class. So about 200 years ago, there was a guy named Antoine Lavoisier, and he was a chemist, and actually his wife helped him do experiments, which was very unusual at that time. And anyway, he did some things that showed that mass is always conserved. And so in a chemical reaction, the mass of the reactants has to equal the mass of the products. And very quickly, there's also something called the law of definite proportions, which means that materials are put together in certain components